Hello everyone, this is Professor Lee. As I told you in class, we are going to study chapter 2.1, the first part of chapter 2 in online version, right? So if you can, please open the PowerPoint file in PDF form that you can download this in our class web, right? The E360 resource section. So if you click on our course, MAT 330, and you click on the resource on the left hand corner, then you will see that our PowerPoint file, right? Okay, so I want you to open up the file as you are listening to this lecture. So we are going to check chapter 2, right? The first thing that we are going to check in this chapter is how to present categorical data and quantitative data. Now remember last week in the first class that we talked about different types of data. Categorical data is non-number form of data, like your name, your major, nationality, eye color, and stuff, right? Categorical means non-number form. Quantitative data, however, right? Quantitative data is number form, right? Quantitative data is number form. Categorical data is non-number form. This is number form of data, right? So categorical data use label or name. Quantitative data is a numerical value, meaning it's a number form. So let's talk about how to summarize the categorical data, right? Let's talk about the number form and non-number form of data, right? So what we are going to use is what's called the frequency distribution, right? Frequency right here in this. Let me just check whether you can see this properly, though. Right? I think I have to put it a little bit down like that so they can see it better. Okay, that's good. So the frequency distribution is something like a table, something that looks like a table that we are going to make from what type of data? From the categorical type of data, right? And it provides insight about the data that we cannot quickly obtain by looking at the original data. So, this is an example. Let's say Ramada Inn, this hotel, they had 20 guests, and when they were checking out, they all gave you a feedback, right? So some of them said it's below average, some of them said it's excellent, some of them said it's above average, some of them says poor. So this is the data that we gathered from, let's say, 20 guests, right? 20 guests. So from that 20 guests, these are the feedback. So what do you think about this feedback? Well, when you look at this table as a whole, it's bad drawing. Let me see if I can take this one out. Oh, cannot. Anyway, it's kind of hard to see which one's which, right? So what you are going to do, you make this what's called the frequency distribution. What it does is, organizing this data into a table. So let's see how many people said it's poor, right? Going back to this person said it's poor, and this person said it's poor. So only 2 of them said it's poor. So we have 2 there. Now going back to this original, how many said say for example, excellent, right? And looking at this, only one of them, right? Only one of them said it's excellent, right? It's kind of tricky. So only one of them said it's excellent. So going back to here, that must be just one. So if you actually, from this raw data, categorical data, if you organize that data into something like this table, of course it's a lot easier to see, right? You can also see that the total is 20, right? So total 20 of them. It's kind of tricky to use. Total 20 of them answer this question that we knew before, because it says 20 guessed, right? So if you organize your data into this table form, of course it's a lot easier to see. You know exactly how many said above average, which is the highest frequency. So majority of them, out of 20, like 9, which is like close to 10. So about half were saying it's pretty good, right? Above average, right? And a couple of them that says really poor and below average and stuff. Now, once you make this frequency distribution, so what frequency distribution? Well, frequency distribution is basically this table. Something like this table refers to a frequency distribution, right? This table is called frequency distribution. So, the exam question, for example, give you something like this table form, of data and ask us to construct or make frequency distribution. What do we need to do? Well, we need to figure out this table, right? Figure out what are different rating and figure out each category, how many answered, right? Like that. Now, there are frequency distribution, or there's also what's called the relative frequency and percent frequency distribution. So these are pretty similar to our original frequency distribution. So let's check out the relative frequency. Now, for example, in here, excellent, we got 0.05. Where do we get 0.05? Well, going back to this original one, we had 1 out of 20 answered, 1 out of 20 answered, it's excellent. So this 0.05 actually came from 1 divided by 20. Then it's 0.05. That's how they got this 0.05, right? So 1 divided by 20. So for example, this poor, we remember that out of 20, 2 of them says it was poor. So we have 2, for example, this is from 2 divided by 20. Let me see. 2 divided by 20. It's kind of hard to see, hard to draw here. Divide by 20. Then, which is 0.10, which is what we have right there, right? And so forth. So they got these numbers from basically this frequency distribution table, right? This frequency distribution table. Okay, so if you add all this relatively frequency here, if you add all that, then it becomes 1. Total must be always 1, right? Regardless of any data point, the frequency distribution that you have, this must be always 1. Now, well, once you construct this relative frequency, how do you make the percent frequency? Well, you just convert this decimal number into a percent. 0.01 is 10%, of course. 0.15 is 15%. and so 0.45 is 45%. So if you add all this percent, now it becomes 100, right? So both of this came from basically sorry about this table is just not cooperating. Okay, that's good. So that percent frequency table is also basically from here, right? You get the relative frequency first, then you convert the relative frequency into percent frequency, just like that. So if the question says construct relative frequency table, then you are going to construct this part right there, right? This part. Okay. Now there's also what's called a bar chart. And if you take a look at this chart, it's not that difficult to see where and how they got this bar chart. Now remember that two of them says poor, so it goes up to 2. Remember that one of them said excellent, goes up to 1. And 9, I remember 9 of them says is above average, so it goes up to 9. So basically you are converting this table into basically this graph, and they use this bar, so that it's called the bar graph, bar chart, right? So if the question says graph the bar chart, then we are going to convert the table into this chart. We also have to, I also want you to notice that between each bar, there's a gap between it. So there's a gap here, there's gap here, there's gap here, there's gap here. So they don't put the bar connected to each other. They leave some space between each bar, right? Okay. Now there's also what's called the pie chart. The pie chart is basically converting this frequency table into something like a pie graph, right? I mean, we've seen something like this pie chart everywhere, right? We've seen it in the advertisement. We've seen it in this in something like this pie chart in the magazine, newspaper, right? We've seen it in many different places. So, above average was 45%. Where do they get this 45? Well, if you go back here, it's 45 right there, right? Percent. So 45 in this whole pie, 45% would be this much, because what would be the half pie? Half pie would be like 50%, right? Half pie would be 50%, so it's like 45% is almost like 50, right? And average, for example, was 25, right? 25%. So 25% would be a quarter pie, right? Which is about this much. So that's how you're roughly getting the general shape of this pie chart. Okay, so summarizing quantitative. Now let's talk about quantitative data, right? So far we talked about qualitative, not the qualitative data or the categorical data or something like a name type of data. Now we're going to talk about quantitative data, which is the number form of data. So again, same thing, almost the same thing that we can do. We can build what's called the frequency distribution first. So let's check out this example. So at Hudson Auto Repair, the manager examined 50 customers' invoice for engine tune-up and how much they actually paid for, when they come to the shop. And she were able to get all this 50 data point. So those 50 customer, some of them spend $91, some of them spend $109, right? These are all 50 tune-ups that Hudson Auto Repair had. Now, what she's trying to do, she's trying to organize this number into data form, right? Into a data form, the graph form, right? Organize this data into a graph form. So first, in previous case, the categorical, we didn't have to set these different types of category because it was already there in the original data. But in quantitative, the number form, there's no categories, just 50 different number. So first thing that we should do, we should figure out what's called the class, right? It says it right here, what's called the class. We have to figure it out, how many different class that we are going to use. So how do we set this class? Well, what you do, if this is the formula to setting up the class, what you do, you figure out which one is the largest value and which one is the smallest value in that data, and you subtract that and you divide that by the number of class that you want. They usually use anywhere between 5 to, kind of difficult to write. Let me go back, undo. It's kind of difficult to undo either. Oh well. So let me rewrite it here then. Let's see if that works. So number of data is going to be anywhere between 5. It's not really working. Let me try it again. Try that again. So 5. See, once I take it out from this writing pad, it's not working. So just take a note. This number of class is going to be anywhere between 5 to 20, right? And who's going to decide how many classes that we are going to use? Well, we can decide. As a project manager, you can decide. In many of our case, the question will actually say use 5 different data class or 6 different classes. They'll say it for us. But if this is like a real case, then we have to use our own judgment and figure out how many number of class that we are going to use. So as you can see, the highest value in that data set was 109. The smallest value was 52 in that. This is from actually this original data. 109 right here, right? And 52, where is 52? I guess 52 is right there. So these two are the smallest and the largest value, right? So that's how they got this and this number. And they divide this by 6, meaning 6 is the number of class that they want to have. That's why they use 6 here. So number of class means what? Number of lines. We have 1, 2, 3, 4, 5, 6 different lines in here, right? So 6 data, so we have this 6 different line. Now each class should have, according to this formula right here, each class width, and we're going to talk about the class width. Each class, largest data minus smallest data, divide by number of class. So, if you subtract this and divide by 6, we get something like 9.5. If it's now 9.5, we round it up to the next number. 10. You know, if this was 9.2, should we use 9 here or 10 here? Answer is 10, right? Even though we have like a small number here, 9.1, 9.2, 9.3, we still are going to round it up to the next biggest number, which is 10, right? So what does that 10 mean? That means each class will have 10 different number. That's what it means. Each class will have 10 different number. Each class will have 10 different number. So, the smallest number start from 52 and the biggest number goes up to 109. So look at how they set up these classes. 10 number starting from 50. So 50, 51, 52, 53, all the way up to 59. You in that class, if you count it, you actually have 10 different number here, right? And next one again, because you finished at 59, the next class will start at 60, goes up to 69, and so forth. So it goes all the way up to 109 there, which is our biggest number. So if we set it up like that, it will definitely cover every single number in our original data set. Now, once you set it up like this, then you figure out how many data that we have between 50 to 59, right? 50 to 59. So let's see. We know this one has 50 to 59. And anything else? This one, right? This one also has between 50 to, oh, that 5 is just not writing, right? Oh well, 5, I can't really even delete it. So this 52 and 57, any other numbers in the 50s? Not really. So we have 2. So that's how they got this number 2, right? Number 2 there. And let's see how many numbers that we have between 60 to 69. You go here, you count each one of them between 60 to 69. Then it turns out to be 13 of them. And if you count data value between 70 to 79, then it becomes 16. And data value, for example, between 100 and 109, you have 5 of them. Now, if you actually add all this frequency, then you know it's going to be 50, right? You know it's going to be 50. Because why? Because we had 50 different data point, right? 50 different data point. Now, once you get this frequency table, now you can get the relative frequency table. Now, so where do they get this 0.04? Well, there was 2 out of 50, right? So 2 divided by 50, then you get 0.4, right? 2 divided by 50, then you get 0.4. Where do they get this 0.26? 13 divided by 50, then you get 0.26 right there, right? So 13 divided by 60, you get 0.26. And where do they get 0.10? Well, same thing. 5 divided by 50, then you get this. Once you set up this relative frequency, you know how you get the percent frequency, right? It's kind of obvious. You change that to percent. This is, you just drop this point, move it two step back, so it becomes 4, 26, 32, 14, and 10. So if you add all the percent frequency, of course it's going to be 100. If you add all the relative frequency, it's going to be 1, right? Now when you are doing this lecture, I want you to actually, you know, pause it every now and then and try all this calculation by yourself. You know, when you are looking at this with me, it makes a lot of sense. But when you try to do it by yourself, I'm sure it can be very confusing, right? So, you know, once you build this frequency or relative frequency table, right, then it's kind of a lot easier to see. You can see that, you know, 32% of customer paid anywhere between $70 to $79, which is the biggest portion because that's the biggest percent, right? Only 10% spend more than $100 and 4% spend less than $60, right? Or anywhere between $50 to $59, right? So once you, rather than looking at this entire data, right? Once you summarize it like this, a lot easier to see a lot of things, right? So they're talking about that, right? 4% between this, 30% under $70, right? And 10% spend more than $100 and so forth. You can also use what's called a dot product. Convert that raw data into something like this dot. Remember that 52 was one of our lowest value. That becomes this dot right there, right? And 57 was the next one, so we got another dot. So this is almost like that stem and leaf plot, right? Only in a slightly different form, and you use this dot to present all those different data points, right? Okay, now the histogram. Histogram is another graphical representation of the data. So you can use the frequency or the relative frequency or the percent to draw histogram, right? And it looks like this. Remember the first class was between 50 to 59, and what was the frequency? Only two values, right? So it goes up to 2. Between 60 to 69 goes up to 13. Remember that original, let me show you the original, right? 13 between 60 to 69. So goes up to 13 and so forth, right? And notice that this is different from that bar graph, right? Bar chart. In bar chart, there's no gap. There was gap between each bar. Histogram, there's no gap between each bar, right? There's no gap between each bar. Just make it all connected like this, right? Get all connected like this. Now let's talk about, so, histogram, you can see the general shape of the graph. You can describe the entire data into something like this graph form, which is, sometimes visually easier to understand and perceive, right? Now let's talk about the skewedness, right? If it's like right in the middle, right here, and about the same in the left and right side, we call this symmetric, right? Left tail, the right tail, they say this is left tail part. This is right tail part. It's about the same, then it's what's called symmetric. Now, slightly skewed to the left, moderately skewed to the left means majority is in the right side. It's kind of opposite. If it says left, then majority is in the right side. If they say skewed to the right, the majority in the left side, right? And if they say highly skewed to the right, that means, compared to this is more towards the left, right? It looks severely skewed to the left, meaning there's more to the skewed right means the opposite, right? Left side from the middle, there's a lot of data point, right? So that's the skewedness of the general shape of the graph. Now there's another table called the cumulative distribution. Cumulative distribution is actually you are adding up to the you are adding up from the previous class. So remember, the up to 59 we had 2, and between the 60 to 69 we had 13, but now we're not going to write 13, we're going to write 15 because we are adding it up from the 2, right? So you have 15 there. So 2, between 60 to 69 we had 13, so we add it up like that. Now how much did we have between 70 to 79? Right? Let's go back to this original graph. 70 to 79. 70 to 79 was 16, right? 16 that we had. Now, okay, so to 15, we are adding up 16. So 16 plus 15 becomes 31. That's how they got this 31. So you keep adding it up from the previous, and then you get up to 50 there. So once you keep adding it up, get this cumulative frequency column. Now convert that into a percent. I mean, divide it. Out of 50, you got, for example, here, 0.30. Out of 50, you got 31 out of 50 becomes 0.62. Out of 50, you got 45, which is 0.90. And you convert that into percent, then you have this column right there. So what do you do with this table? Well, you convert that into the graph that's called ogive, right? Which refers to the cumulative percent frequency. So this side right here, the usual Y side, you have cumulative percent frequency, and this left side, the X axis becomes from 50 to 100. So it always starts from 0 here, right? Notice that it's always start from 0. Between up to 59 we had 2. So right above 59, then you got 2. Up to 69 you have 15. So up to 59, I'm talking about the percent, sorry. So up to 59 we had 4. The next one was 30. So we had 4. This line refers to 4. Next one is 30. And then the next one is 62. So it goes up to 62 and so forth. It goes up to 100. Then once you get all this dot, you connect it with a straight line, and there you have it. This is what's called ogive, the cumulative percent frequency graph, right? So this is another graphical representation of this table, right? Basically from the 50 row number form of data. All right.